Good morning, student. As we finish till here, the periodic law, the cause of periodicity in reoccurrence of similar electronic configuration, which means that in a particular group, the number of electron in the outermost orbital remain the same. As we learned in last class, that lithium, sodium, and potassium and rubidium, cesium, and francium continuously, the outermost electron, here you can see this lithium have a 1, sodium have 1, potassium have 1. So in this electronic configuration, the outermost electron is a same number. Okay, in second group, this is the first group, second group have also a same number, 2, 8, 2, like this. Okay, so this is the way this periodicity, the same number of outermost electron present, so that is why they have a same type of property, similar property. So the element of the same group have a similar property. So throughout the number or cell increase the group down the group, which means that this number of cell increase, this the number remains same, but the number of cell here, the 1 and 2, which means there are 2 cell here, 1 2 3, so 3 cell here, 4 cell. Okay, so the number of outermost electron, that is 1 1 1, remain in a first group same, and but the number of cell is increasing because the atomic number is increasing. So the cell are increasing, but this is remain same. So that is why the chemical property and physical property is same in a throughout the group. Okay, now next move on to the periodic table, the now latest and modern periodic table. Some features, so silent features are given, that first we know. So first you underline this, International Union of Pure and Applied Chemistry, IUPAC. This is the organization for the all over the world for the particular chemistry, whatever the scientist publish his research, that research is first they have to take a permission from the IUPAC. This is called International Union of Pure and Applied Chemistry. This is the way physics also, IUPAP, International Union of Pure and Applied Physics, that is also. So in chemistry, so this organization have decided the group number. So group are a number from 1 to 18, replacing the older notation of a group 1A, 7A, 8, 1B, so on. So this numbering, this Roman number now is replaced by this IUPAC, that is 1 to 18. So nowadays the digital number 1 to 18 is given here. So this is the way the first A given first number, second A second number, third B third number. This is the way the till 18, that 0 group in periodic table, now it is a 18 number group. So this is the way they are changed. Now the another silent feature are given. The first silent feature, that is the first we'll talk about a group. So here it is given the group in your textbook, the silent feature. So first one, the modern periodic table has 18 vertical column. Okay, step by step I will explain the every single thing which I have a particular periodic table. So I will show you this periodic table like this, or if you cannot able to see here, you can open your this one. Okay, so there are total 18 column which are given. So this 18 column are considered as a group. Okay, and this 18 column have second point, now that group 1 to 7 are divided into the subgroup, thereby making total of 18 groups, which means that those who are in a subgroup, now they are considered as a single or individual group. So that's why there are 18 groups. Okay, now element of the subgroup A of 1A, 2A, 3A and 7A are known as a main group of elements, or representative elements, or a normal elements, which means that this group, here it is given in your textbook on page number 84, that first A, second A, third A, 4a, 5a, 6a, 7a and 0. All these group are known as a representative group. Okay, first group, second group, then a third A, which means 13 group, 14 group, 15 group, 16 group, 17 group. These groups are a representative group. Underline this, representative elements we can say, or the main group of element we can say. Okay, because they this element have their outermost cell incomplete, which means that outermost cell incomplete, as I show you here. This is the incomplete outermost cell. Here the capacity of the second cell, this is first cell have a 2 and second cell have a 8 capacity to fill electron, but here instead of 8 it is written 1, 2, 3, 4, 5, 6 and 7. So these are incomplete. Complete, which means that here the 8 is completed, which is a what is neon. Okay, neon it is. So this neon have a complete electronic configuration. There are 8 electron can accommodate or hold in a second period, which is a second cell. K, L, M, N. I told you 2, 8 here and 18, 32 like this. So the two second cell, this is first cell, second cell, third cell and fourth cell. The second cell can able to hold 8 electron, but if there are not 8 electron in second cell, which means this is incomplete cell. So this is the incomplete cell. So here it is given what is this element have their outermost cell incomplete. So the first group, second group, then 13 number group, 14 number group, 16 to 18, all the elements do not have a complete electronic configuration. So they are incomplete. Remember this thing and you can underline this. The representative elements and these elements have their outermost cell incomplete. Okay, now the third one, the element of group number third to 12, which means that which are not given in this, which is are given in your text in your periodic table. This middle one, this block, we can say that this much of block, which is a third to 12. This element are known as a transition element. What is the name of transition element? These are the representative element. This is called a transition element. Transition, which means that the property are changing one by one property are changing, which means that these all are a metal, and from one group to another group, the property are transfer from one to one. So that is why this is called a transition element. Okay, now they have their 2 outermost cell incomplete. Okay, that about right now you just need to remember only the 2 outermost cell incomplete, how and why and everything that you will learn in 12th standard. It is not coming even in 11th standard. So right now no need to understand, no need to ask about this, the why there are, which are the outermost cell incomplete and everything. Just right now you need to remember what is the transition element, which are the transition element, and they have a 2 outermost cell incomplete. That much only you need to remember about that. Okay, now the fourth one, the element in a zero group, which means the 18 are called inert gases. Inert, which means that which do not react with anyone, do not interact with anyone, they do not combine with anyone, which is called inert. So that's why they are, and they all are present in a gaseous form, and very less amount of the gaseous form present in atmosphere into the atmosphere. So that's why it is known as inert gases or noble gases. They all are present in a gaseous form. So because owing their stable electronic configuration, which means that here 2, 8, here also 2, 8, 8. This is called a octave completed. This is called octave. Octet, which means 8, and those whose electronic configuration that 8 octet is completed, which is a completely stable. So except helium can only accommodate helium have a 2 electron, and which is a K shell, and K shell only can hold 2 electron, and that 2 electron is fill in a K shell and which is completed. So third electron is not there, so no need to go into the second cell. So that is why here, except helium, other noble gases have completed their octave, and that is why they cannot react with any other. So their stable electronic configuration, they hardly react with the other element. So 8 electron in the outermost orbital, as I told, 8 electron in the outermost orbital. So except in case of the helium, which has a 2 electron. I hope till here you understand very well. Okay, now the next one, the periods. Periods, which means that in periodic table, the horizontal line is called as a period. In short, I am telling you, there are number of cell represent, like hydrogen have a 1 electron, so its electronic configuration only 1, and so this is the first cell. Okay, one first cell for first period. There are 2 cell, second period. There are 3 cell, third period. There are 1 2 3 4 cells, so 4 cells, so that's why fourth period, and fifth, 6th, 7, like this. So that's why here there are total 7 period in a periodic table. So here there's 1 to 7 table in a periodic table. Okay, now here another thing, this periodic table have a number of element. As I told you that obviously you can see that the first period which have only 2 element, which is known as a shortest period, which means that they have only 2 element present in it, hydrogen and helium. Second period also have a 8 number of element, 1 2 3 4 5 6 7 8 number of element in a second period, like this. So here it is given in your textbook. You can see that there are 7 horizontal rows in the modern periodic table, and each call a periods, and the number of cell represent in an atom determine its period, and as it is clear from table number 5.2. Here it is given on table number 5.2 that shortest period, number of element 2, atomic number of element, that is first hydrogen and second, first to 2. Okay, so first to second, both are present in a first period, and number of shell 1 only, which is hydrogen and helium. Okay, second it is given the element which electronic increasing the arithmetically in their outermost cell 1 by 1 till an octet is attained as placed in the same period. The last element of each period has 8 electron except the first helium, which means that here I am telling you the second period. First period have a first hydrogen and the helium, as I told you. Now the second period you can see that the 1 by 1 electron is increasing. Here 2 1, beryllium 2 2, boron 2 3, carbon 2 4, nitrogen 2 5, oxygen 2 6, fluorine 2 7, and neon 2 8. So the 1 by 1 electron are increasing, okay, till the last element have 8 electron, which means octet is completed. So here the 1 by 1, this number of cell remains same, but the number of electron are 1 by 1 increasing in throughout the period. Okay, so that is the last element of each period has 8 electron except the first period helium, which is a 2, which I told you before just. Okay, that you understand. So now second, the first period contain only 2 elements, atomic number 1 and 2. So it is the shortest period, right? As I told you, this first period is the shortest period, which have only hydrogen and helium element. Second period contain 8 element, atomic number 3 to 10 in the second, and atomic number 11 to 18 in the third period. These are the short periods. Okay, here the first here it is written on table number 5.2 in your textbook. So the first period is the shortest period. The second and third period is known as a short period, which have a 8 element. Third to 10 and 11 to 18 are present in it. Here it is given lithium to neon and sodium to argon. Okay, here this is. So that is why it is a short period. Okay, number of element need to remember for exam point of view, that how many element present in a particular number of period. That type of question asked in exam, so you need to remember for that. Okay, now the period number 4 and 5th both are known as a long period, which have 18 element, which have a 18 element, 19 to 36 and 37 to 54, potassium to krypton and rubidium to xenon here. Okay, potassium to krypton and rubidium to xenon. So the 4th and 5th contain 18 element each and these are long periods. Okay, now the 6th period contain 32 element, atomic number 55 to 86, and it is the longest period. Okay, shortest, short, too short, too long, then longest and longest. Okay, so 6th period also longest period, and 7th period also considered as a longest period because the 32 element present in it. So atomic number 87 to 118, it is also a longest period. Okay, now the in a last period few students asked me about the actinide and lanthanide, why the F block are given below in this. So that is here the reason is given that in a group number 3rd B or group number 3 of the 6th period. So that I am showing you here. Here what is given in your textbook, I am reading from your textbook. Okay, so in a group number 3rd B, the 6th period, this is the 6th period, and the set of the element 6th period and 3rd element, which means this is this LA here, star also given. So the 6th period, there is a set of element which atomic number 57 to 71. This side the 71 till 71 is okay, 71 or 57 to 71, and that's a beginning with the lanthanide. Here the 57 to 71 this is given here, the 57 given here. Now the 58 till after the 58 here in F blocks. See, 58 to 71, first one, this is, so this after the lanthanide, this is the lanthanide La, which means lanthanide. So after the 57 58, that's why after the 50 the lanthanoids, this particular row is known as a lanthanoids. Okay, and this lanthanoids, this is which is a rare earth, which is known as a rare earth, which means in earth crust it is found, all these elements are found in a earth crust, and very rare amount of the substance, very rare it is present in a earth crust. And after the 8 point in your textbook on page number 85, in a group 3rd B, or number group number 3rd and the period 7, element atomic number 89 to the 110, beginning with the lanthanide. Here the lanthanide, here the 9 after the 89, so which means 90 to 103. This is the called actinide, this is the actinide. So this element are known as actinides. Okay, so the actinides which is a radioactive substance, a radioactive element, this is called a radioactive element. radioactive elements. These are the radioactive elements, and these are the rare earth, and these are also known as a lanthanide and actinide. So some students have a question arise in their mind that why it is not present in this periodic table after this. So because that here the reason given in your textbook that lanthanides and actinides have been similar property because they belongs to same group. Okay, so the group third B, but they showed at the bottom of the periodic table because they are larger in number. They are big number. If we put all these numbers from 58 to 71 and from 90 to 110, this number we put into the periodic table, then periodic table will be distort, which means it's look clumsy, it's not look good. So for looking good, they have to prepare like this. So because of they have a similar type of property, so they put this lanthanoids and actinoids in a separate place in periodic table. So that's why this periodic table can able to make in A4 size paper. So to look good and for the better arrangement, this F block and this lanthanide and actinide are put into the separate group. I hope you understand about this F block element or radioactive element. Here the rare earth and the radioactive element, you underline this in your textbook. So which is given lanthanide known as a radioactive and lanthanide known as a rare earth and actinide known as a radioactive elements. And behind why they put separately, that reason also given. But this reason is not will ask in exam, but for your information it is given. Okay, from till here the overview of the periodic table you know about. Okay, now step by step we learn about all the groups which are known, particular the name is given. Okay, now the type of elements present, representative element, as we told before. Which are the representative element? Group 1, group 2, group 3, group 13, 14, 15, 16, 17 and 18 are known as a representative element because they have a one incomplete outermost cell, and this also known as a normal element and representative element, as I told you. Okay, transition element which means that the middle part, which is the group 13 to group 3 to 13, which is a transition element. Okay, then the inner transition element which means that the lanthanide and actinide are known as inner transition elements. Okay, inner transition also, the inner the property are entire property are changing step by step, so that's why it is known as a inner transition element. Okay, now then the inert gas or noble gas, that is the 18 group that you know. Here I repeat one more time, representative element 1, 2, 13, 14, 15, 16 and 17, that is the representative element. Transition element are a 3 to 13 group. Inner transition element lanthanide and actinide, and inert gases are a 18 group. Okay, which is also called as a 0 group, noble gases. Okay, now the classification according to S, P, D, A and F block is based on electronic configuration, which you will study in higher class. Here it is particularly mentioned that about this definitely not 101% about this will not ask in 9th and 10th standard. It will be coming in 11th standard. So don't ask me about this S, P, D, F now onwards. Okay, here also particularly mentioned that you will learn in a higher standard. Next point, that the representative elements, first we learn the representative elements which are 1, 2, which is S block, which are 1 and 2 which is S block, and the 14 to 18, which are P block. Okay, so that is a representative element, or 13 to 17 I can say, 13 to 17. Okay, so the S and P block element, Element which have their outermost orbital is orbit incomplete, they include all the element of first group, which is known as a alkali metal. Okay, remember, or you can write here in your textbook this first group here. This is representative element also given, S block also given, but here you can write alkali. You can write alkali, and second are known as a alkaline earth metal, alkaline earth, that you can write in your textbook with pen. Okay, if you cannot able to write with pencil. So element which have their outermost orbital incomplete, they are including all the group 1 alkali metal. From the strong alkalis with water, form the strong alkali with water and except hydrogen. Except is not, hydrogen is not present in, not give any alkalis with the water. Okay, so what is the meaning of this? The alkali form a strong alkalis with water, which means why they are known as a alkali, because suppose the sodium, I am talking about sodium or potassium or lithium, then when they lithium, sodium and potassium when react with the water, they convert into the lithium hydroxide, alkali. This is alkali, or we can say that's base. That same way, N plus H2 gas evaporate. Okay, so you balance it. Right now I'm not doing so. NaOH, it is from NaOH. NaOH is a base. H2O, alkali, this is alkali. So KOH, so it is a alkali, so base it is. So this is the way all the elements which are present in a first group are react with the water and form alkali. That's why these elements are known as alkali metals. Okay, except hydrogen, because hydrogen do not react with the water. Now the group 2 alkali earth metal form a weaker alkali compared to the first group. Alkaline, which means alkali but the weak alkali, weak base, we can say that, weak base. For example, I am taking magnesium, Mg. When Mg react with the water, it convert into the MgOH twice. So this why N plus H2. So here you balance it, right, like this. So this is the way they form a alkali, but this alkali is a weak alkali, so that's why it is alkaline earth metal, which means that this alkaline earth metal, beryllium, magnesium, calcium, strontium, all these metal are found in a earth crust. That's why it is known as a alkaline earth metal. Okay, so form a weaker alkali compared to the first group elements. Group number 13, which is called a boron family, because the first element is a boron. You can see in your textbook which is given the boron family. Okay, wait, I'll show you here. Okay, this is the boron. So the boron family. So this boron family, boron is the first member of the group. Okay, boron family. Then the group number 14 carbon family, carbon being a first member. This is the first carbon member of this group, that is why it is known as a carbon family. Then the nitrogen family, 15 number, nitrogen family, and because the first member is a nitrogen. Then the oxygen family. Okay, this is the oxygen family, and these are known as not a fluorine family. This is called a halogen. Fluorine, chlorine, bromine are known as a halogen because they are a salt former. We can say salt, which means that they can react with the metal and form a salt. So that's why it is known as a salt formers, like NaCl, right? Cl is a chlorine and Na is a metal. So NaCl is a salt. So that's why they are the salt former. That's why they all are known as a halogens. I hope that you understand till here. That's next point, that is all the alkali metal group 1 are most reactive metal they occur. So they are known as alkali metal because they react vigorously with water to produce hydrogen and alkali solution, hydrogen gas H2 gas and alkali solution. Halogen are the most reactive non-metal. Underline this, alkali are the most reactive metal and the halogen are the most reactive non-metals. Metals and non-metals, which group is the most reactive metals and which group is the most non-reactive non-metal, that is a you need to remember, and they form a salt on reacting with metals. So as I told you, NaCl, so these halogens can form a salt with react with the metal. Na is a metal, so NaCl, KCl, NaBr, all of these are the metals, salt, sorry. So they form a salt on a reacting with the metal. Okay, now so main character of the representative element as we learn for second group and the 13 to 17 group. These are the representative element. What are the main characteristic? They include both metal and non-metal. Alkalis are alkali and alkaline earth are metals, and the in a 13 to 17 metal, non-metal and metalloids also there in it. So there is a regular gradation from the metallic to non-metallic character on move from left to right across the period, which means that here the across the period, if we can see this from this side, all are from right, from left side we can see this is the left side and this is the right side. So from move left side to right side, the metallic form to non-metallic form. So here the most reactive metal slowly and gradually metallic characteristic decreasing, and here the non-metallic characteristic increasing. So some here the you can your textbook, it is a different color given. It is given in a different color, and you can see this different colors, different color. This is the most reactive metal here, so heavy metal. Then these are the metalloids, which means some are behave as a some characteristic are metal like and some characteristic are non-metal like, and these are the non-metals. Okay, these are the non-metals. Inert gases also are non-metals, and these are also non-metals, and here these are most non-metal element. Okay, so that is given in your textbook that you can see. So here this first characteristic is from left side to right side move in a periodic table. The metallic characteristic move on to change and convert into the non-metallic characteristic. Gradually characteristic are changing. Okay, second point, they form electrovalent as well as covalent compound with the non-metal. Now what is the electrovalent and what is the covalent? Electrovalent, which means that ionic compound, and the covalent compound. Electrovalent, which means ionic compound. Ionic compound, what which suppose I am taking Na compound Na and Na plus and Cl minus. So NaCl, they are forming NaCl. This is called a electrovalent. Why electrovalent? Na is donate one electron and form Na plus ion, and that electron is chlorine. This electron is chlorine accept and form a Cl minus. So between them Na and Cl donating and accepting, this Na is donate electron and to Cl. So because of that donating and accepting electron between them, they form an ionic compound. So that is why it is called ionic, or both, or ionic or electro, both same. Okay, you can say ionic or you can say electrovalent. Okay, so this is ionic compound. And we talk about the covalent compound. Then the covalent compound like HCl. So the hydrogen have a 1 electron and chlorine have a 7 electron in outermost. So 1, 2, 3, 4, 5, 6, 7. So here to complete octet they share their electron. So suppose I have one pencil and my friend have do not have, so between two of us we are sharing that pencil. So that is why they share. Between sharing, this bond form, it is known as a covalent bond. Covalent bond. So here they form electrovalent as well as covalent compound with non-metals. Okay, I took a non-metal, sodium and non-metal, metal and non-metal. This is also non-metal. So third point, metallic nature increase moving down any of this 7 group, which means then from top to bottom in periodic table. In periodic table here, this is a top to bottom. This is a from top to bottom. When we move from top to bottom, the metallic nature is increasing, moving down. So we can say that this is a less metal and these are the more strong metal. So from top to bottom, metallic characteristic is increasing, that you need to remember. Okay. Fourth one, the metal which are good conductor of heat and electricity are present in a first and second group. So the non-metal which are present in a group 16 and 17 are poor conductor of heat and electricity, and some heavier element like tin and lead exhibit a variable valency. So tin and lead exception are there which are exhibit a variable valency sometime. So variable, which means that electricity and heat towards their behavior is a different, like from the metal and non-metal. So metal are conduct electricity and heat, but non-metal do not conduct electricity and heat. Okay, next one, the some heavier element that I explained, the variable valencies. Variable valencies, which means that tin, which means Sn have a +2 and Sn have a +3 valency. Pb have a +1 and Pb have a +2. So this variable valency they have. Why they have a variable valency? That you will learn in higher standard. Don't ask me this question. So these are the exceptional case because Sn and Pb have a variable valencies. So these 5, which is very important, these 5 characteristics you need to remember, student. So till here today we are doing about transition element. We will, and that characteristic we will learn in our next class. Thank you.